I recently showed off how to set up a Notify icon in a WPF application, which allows your application to have an icon in the system tray, and it also allows you to show notifications to desktop users. Now I want to take that a step further and implement that in a full MVVM application. Alright, so just went ahead and commented out all the old stuff. So what are we going to be building? Well, let's start off in the view, just so that we can get an idea of what this app's functionality is going to be. So obviously this isn't going to be like crazy advanced. What we're going to be building is just a simple countdown timer, and whenever the timer runs out, we'll show a notification at the bottom. And we'll also have a context menu button on our Notify icon to get the timer status. So on the view, the first thing we're going to have is just a text block. We'll put it in the center, so horizontal and vertically aligned center. It's going to be a massive text box, and it's just going to have the time remaining on the timer. And then we're going to have a text box where the user can enter how long they want the timer to go for, and then we'll have a button to start the timer. So let's throw some padding on here too. I'm also going to need some grid row definitions, of course, and in fact let's just start the live debugger so that I can see these updates in real time, because we are not doing good so far. Alright, so we're going to have two rows. First one will be star, and then the bottom will be auto. So the top one is going to take up all the space, and that's going to be for our big time remaining text block. And then both of these are going to be side by side. So let's surround those with a tag, and this is going to be a stack panel that is horizontal and is going to go in grid 1. And our text box needs some width. Let's give it like 100. There we go, and let's vertical align the text. It's going to be vertical content alignment. There we go, nice and aligned. Let's get some margin to the left on our button. And let's align this stack panel as well. So horizontal and vertical alignment, center. Let me just get some text in this text box so we can actually see this. There we go, that looks good. And I think last but not least, let's just get some margin on the stack panel so it's not touching the bottom. We'll do 20. Alright, so I think that's all we need in the UI for now. Obviously, we're going to have to update this with some bindings later, but pretty simple. Just going to start the timer, and then this would start counting down from 12. So let's create a view model for this, and this is going to be the timer view model. So we'll make that public and inherit from our base view model that just implements iNotifyPropertyChanged. So looking at our view, we're going to need a command to start the timer. So this will be the start command. Let's create a property for that, an iCommand called start command, and we'll set that up later in the constructor. We're also going to have to get this text box input, a binding on the text property, and that'll bind to a property called duration on our view model. And I'm not going to forget, like I always do with text boxes, I like the update source trigger to be property change. So once anything changes in this text box, it immediately goes to my view model. So let's set up that property. So just using my good old prop change snippet, and this will be duration. And I think we just want this to be an int, not a double. We'll see about that. And then last but not least, our remaining time will be a binding to a remaining seconds property on our view model. So remaining seconds is actually not going to be a prop changed, and in fact the remaining seconds is not going to be stored in the timer view model. I'm going to store it somewhere else, because I don't really want all the timer updating logic in my view model. Because what is a view model? It's a model for the view. So I just want it to be pretty simple. So this is just going to be an integer. I don't think it's going to be a double. Just remaining seconds. And it's just going to be a read-only getter that we're going to get set up in a little bit. For now, let's just return 0. Alright, so the remaining seconds and all the timer stuff is going to be in a store. So it's going to store the application state regarding the timer. And I will call this the timer store. And this is also going to have a method to start a timer. And it'll take in a duration as well in seconds. So if we're dealing with timers here, we're definitely going to need a timer. So let's have a timer, and this is going to be from system.timers, not system.threading. We'll just call that timer, and we'll set that up in the constructor. Not take it in through the constructor, just set it up. So just a simple constructor. So the timer is going to be a new timer, and the interval is going to be every second. So every second we want the remaining time to update. So it's like a countdown. And we'll do that update by subscribing to the elapsed event on the timer. And we will set all this up later. So the timer store's main purpose is to start timers, manage the timer, and also give us back the remaining time on the timer. So we're going to have a property for that. remaining seconds. And this is actually going to be a calculated property, so I'm not going to constantly update the remaining seconds somewhere in this timer elapsed. I'm going to calculate it. So the way I'm going to calculate it is by calculating and setting the timer's end time based on this duration in seconds, and then comparing that to the current time. So that said, we're going to be tracking the end time. So I'm going to have a field for that, just a date time, we'll call it end time, and the end time is going to be set up in this start method, and is going to be set to the current time of when the timer is started, and we are going to add seconds to that time and just add the duration. So now we have the end time. So to calculate the remaining seconds, we can take the total seconds of the end time, and I actually had to look up how to do this, so we can use time span from ticks and then pass in our end time, date time, the ticks on that, and then we can get the total seconds, and we can subtract the current time's total seconds from that. So just the same thing, except now we're going to pass in date time dot now, and this will give us the difference between the end time and the current time in seconds. So that means we're going to use this in our timer view model. So we're going to need a timer store in here. So let's just get that through the constructor, a timer store, have a field for that, and that remaining seconds is going to point to the timer store remaining seconds. Oh, and this is a double, so I'll have to change that here, and the reason it is a double is because total seconds is a double, because it could be fractional seconds. Alright, so this is great. We're using a calculated property for the remaining seconds, and then our timer view model references that property. But when the remaining seconds changes, we never raise an onPropertyChanged, so the UI isn't going to re-grab this value and display the new remaining seconds in the UI. So we need to raise a property changed for remaining seconds whenever the remaining seconds actually changes, and that's where our timer comes in. So every 1 second when the timer elapses, we're going to raise an event on our timer store. So let's have an event here. Let's have a basic action, and we'll call it remaining seconds changed. So when the timer elapses, we'll call it on remaining seconds changed, and that's going to be a method that I generate. And inside here, we're just going to raise our remaining seconds changed event. So just invoke it, and whoever is subscribed to this event can be like, oh, I need to re-grab this remaining seconds because that is a new value. So our timer view model is going to use that event. So we have our timer store here, and we are going to subscribe to remaining seconds changed. So create an event handler for that, and inside here, we are going to raise our onPropertyChanged for the remaining seconds so that our UI is going to get updated. And we should also call onRemainingSecondsChanged right when we start the timer as well. And in fact, we should actually call it timer.start inside of the start method. Can't forget that. So now we're almost ready to test this, except we have not set up our start command. So let's create a command for that. Call it the start command, extend our base command, and this start command is going to need our timer store. And we're also going to need our timer view model so that we can get the duration that the user wants for the timer. So let's generate a constructor for all these, and when we execute this command, we're just going to take our timer store and start the timer using the duration from the view model. And now we got our command, so back in our view model, let's set the command to a new start command, pass in this view model instance and the timer store. So that should all be good. All we have to do now is change the data context of our main window to a timer view model. Actually, I'm going to start moving all of these to fields. So we're going to have a timer view model, generate a field for that. We're going to have a timer store, so import the timer store, instantiate that, and I'll generate a field. You'll see why I'm doing fields in a little bit, because we are going to have to use these in other methods within this class, so I want them in fields. And now pass the timer store to the timer view model, set the data context to my timer view model so that we can bind to those properties, and we should be good to go. Let's test this. And the first issue is that before we start a timer, we get this crazy negative number because we haven't set the end time in our timer store. So we're going to have to fix that in a second. But let's do a 10-second timer, start that, and it is working, except it's a decimal because we now have a double. So a couple things we have to fix here, and it can also go negative too. So we got to trim this so that it can only be at 0. So let's update all of that, fix those bugs. First off, for the remaining seconds, we can just have a string format here, and I believe N0, so it'll be a number with 0 decimals. I believe that's what that stands for. We'll have to check that. And then the timer store. So the remaining seconds, I think all we have to do is make sure it doesn't go under 0, because that initial bug where we haven't started the timer and it shows this is under 0. So as long as we never let it go under 0, we won't have this startup issue too. So the easiest way to fix this is we're just going to duplicate this and change this top property to end time, current time, seconds difference. And we can also make this private, don't need to expose that. And then we can use that property in remaining seconds. And if it's greater than 0, then we will return the end time, current time, seconds difference. Otherwise, we will just return 0. Alright, there we go. We get 0 when we start. And now we start the timer, and we are counting down. You can also start a timer while it's already running. So there we go, we get a new one. So we actually spent a really long time setting this up. Let's get to using the Notify icon. So the first thing I want to do is get the context menu going. So I'm actually going to uncomment these two. And we are going to have an on status clicked. So we'll go ahead and uncomment this one too. And what we're going to do is on the status click, we're going to find out if the timer is running. So inside of my app, I have access to the timer store since I put it in a field, so we can check if it is running. So I'm going to put a property on the timer store to check if it's running. And this will just be a boolean is running. And obviously the timer is running if the remaining seconds is greater than 0. So that's all we need to do there. Pretty straightforward. And now we can use that. And if it is running, the status is going to be timer is running. And if it's not, timer is stopped. And we'll just pass that status into this message box. Cool, so let's see this. So right click, check the status, timer is stopped. Let's do a 10-second timer. And then check this again, timer is running. Cool, so our status is working. So now let's do a notification for when the timer completes. So we're actually going to do all the notification stuff within the timer store. So it's going to be something like this. So if the timer was running, so we'll have like a field for was running, and now the timer is not running, then we're going to raise some kind of notification in here that the timer has completed. And let's get a field for was running real quick. So just generate that. And was running, we will set after each timer elapse to the current value of is running. So now this expression should work correctly. Whenever the timer stops, we can raise the notification. So all we need is the notify icon inside the timer store, and then we can just raise the notification. Now one thing I think is kind of weird is actually having the notify icon in the timer store, because I feel like it's poor separation of concerns between the UI and my application's logic. I feel like the notify icon is mostly UI. So one thing I like to do is create a service, so an notification service, and then we'll make this public, and it'll just have a single method to notify. So this notify will take a title and a message and the timeout, how long to display it, and also the tooltip icon. And then I can just depend on a notification service in my timer store. So we'll pass something like that in through the constructor and put it in a field. And now I can wrap the notify icon in a class that implements that interface. So this will be the notify icon notification service, and implement that interface. We're going to be wrapping the notify icon, so we'll get that through the constructor. And then we can just delegate all of these parameters to the notify icon show balloon tip. So by doing this wrapping, we no longer have to refer to these as balloon tips. We can just refer to them as notifications, and then pass in all of the parameters. So the title, the message, and the icon. And since we're wrapping this, you might also want to consider wrapping the enum, since that is in the system.windows.forms namespace, but I feel like that's a little bit overkill. In fact, you might think all of this is overkill. You might just want to pass the notify icon to the timer store. But I do like to wrap it just for separation of concerns. So now back in our timer store, we just depend on this interface rather than the notify icon. So now we can use our notification service and notify. So the title will just have timer. The message will be the timer has completed. Show that for 3 seconds, and we'll have a tooltip icon of just info. And let's update our app.xamos, so we need a notification service in here. And that'll be a new notify icon, notification service. And we simply pass in our notify icon. Dang it, so since I imported the tooltip icon namespace, system.windows.forms, that's conflicting with the timer in system.timers. So I'm going to do the same thing I did earlier and just alias this namespace. So now we can just use forms down here, and everything should work now, no conflicts. So let's do a 3-second timer, and there we go, we get the notification. So we can click that, dismiss it. But what if I want to click it and actually do something? So maybe I want something like click here to restart the timer. So ideally what I would do in this timer store is subscribe to the balloon tip clicked event on the notify icon. Balloon tip clicked, yep, that's what we would want to subscribe to in the timer store, and whenever that was clicked, we'd handle that event by just restarting the timer. But since we're using a notification service instead of the notify icon, we can't subscribe to that method from inside the timer store. So what we can do in our notification service is just create our own event. So we'll have an event, and we'll just do a simple action, and we'll call this notification accepted. And now in the notify icon notification service, we'll implement that, and we'll raise this event whenever the balloon tip is clicked. So let's create an event handler for that, and we'll just invoke our notification accepted event. So we're basically just re-raising the balloon tip clicked event as a notification accepted event, and now in the timer store we can subscribe to notification accepted, and if the notification is accepted, then we can start the timer with the duration in seconds. But we don't have that, so let's track the last duration in seconds in a field, so generate a field for that so that we know how long to start the next timer for, and we'll set the last duration in seconds whenever we start a timer. So now we can restart the timer with the correct duration. So let's see this in action. It's pretty exciting. So we'll do 3 seconds, start that, 3, 2, 1. Alright, let's restart the timer, and there we go. So timer gets restarted. So that's great, pretty useful, but you might be using this notification service all throughout your application. So a user might click a notification that wasn't this click here to restart the timer notification. It might be a completely different notification. So basically this event handler to restart the timer might get triggered for a different notification, and that's not good. We only want this timer to restart when the notification that got clicked was the restart timer notification. So one way to fix that is to have notification types. So in our notification service, we're going to have an enum for notification types. We'll just call it notification type. And all we have is one notification type for restarting the timer. And we can pass the notification type whenever we call notify. So we can keep track of the current notification type. So let's update our method right here. And as I said, we are going to be keeping track of the notification type. So let's create a field for that and store the last notification type in there. Generate that field. And now that we have this last notification type, when the notification gets accepted, we can pass the last notification type as a parameter to this action. So we can invoke this event with the last notification type, and we're going to have to update our interface as well. So there we go. So back in our timer store, this notification accepted event handler is now going to take the last notification type. So if the last notification type was a restart timer notification, then we're going to restart the timer because that's what the notification was asking about. So we're going to have to pass in that notification type in our notify method, can't forget that. So this is a notification to restart the timer. So when it is clicked, the last notification type will be restart timer, and we will start the timer again. So testing this out, there we go, we click and restart the timer. And just to demonstrate a different notification type, we'll have another one just for timer complete. So in our timer store, this notification, we're just going to tell the user that the timer is complete. So we're not going to tell them that they can click here to restart the timer. It's just a timer complete notification. So let's try that. And now when they click that notification, it's not going to restart the timer because the notification type that we passed in was not one to restart the timer. So now we support different notification types, and that's another reason why it was nice to wrap the notify icon in this class, because now we can track additional state regarding our application, such as this notification type. Alright, so the last thing I want to do is clean up our memory leaks. So we do dispose of our notify icon, but we also have some leakage by subscribing to these events because we never unsubscribe, which isn't really a big deal because this timer store and also this timer view model where we subscribe to this event, these are all singletons, so it's not going to be like a massive leak that just grows and grows over our application's lifetime, but it is good to take care of them now. So all we're going to do for that is implement iDisposable, and we'll unsubscribe from those events, and same thing in the timer store. And in fact, we're not just doing iDisposable to dispose of the events, but we also need to dispose of the timer, which is just as important. So let's do all that. Let's call it timer.dispose and unsubscribe from our notification accepted event. And then when the application exits, we are going to dispose of the timer store and dispose of the timer view model. Actually, I think I should dispose of the timer view model first because the view model uses the store, so order might kind of matter there. But anyways, now we're cleaning up our resources, and we have successfully used the notify icon throughout our semi-advanced application. So we got the context menu strip for the timer status, we got notifications that we wrapped in a notification service, which allowed us to track some additional state regarding the last notification type so that we could support multiple notifications that are accepted. Alright, so now I'm definitely going to be using this application in my everyday life. So the seconds until New Year's, we have about 636,000, so I can start this timer, and now I'll be notified when it's finally New Year's. I'll be just sitting here 11:59 just waiting for this to go off. In fact, I don't even have to wait for it to go off. I can be working on other stuff because I'm gonna get a notification when it goes off. That is so exciting. Alright, that's enough messing around. If you have any questions, criticisms, or concerns, be sure to leave them below in the comments section. But other than that, leave a like or subscribe for more. Thank you.